Okay, I hope you guys all did a little stretch break, a little brain break. So we're going to finish off with example 3. So we're going to talk about how if you have a repeating decimal, how do you go ahead and write that as a fraction if you don't know what the fraction is, right? Some of them we're familiar with. 0.3 repeating is 1/3. So if we look at this first one, I have 0.7 repeating. So how do I write that as a fraction? What's important to note here is my algebraic equation that is given to me is saying that n is equal to 0.7. So my first step here is to first multiply both sides of my equation by 10. Okay, reason we're doing that, so I have n is equal to 0.7 repeating, means the only digit that I have repeating is the 7. So I only have one place value repeating in the 10th place. So I'm going to take both equations, and you're going to see in a minute why we're going to multiply that by 10. So then I have 10n is equal to, if I take 0.7 repeating and multiply by 10, that means my decimal moves over here, and I have 7.777 repeating. So the reason we're multiplying that by 10 is because we're interested in getting this first placeholder here, right? If I want to write it as a fraction, I want to see that number. I don't want a 0 here, so I multiplied it by 10 to scoot those over one decimal place. The next step here is to get rid of this repeating decimal part. So if I have 7.7 repeating and I want to get rid of the 0.7 repeating, I can subtract it out. So I'm going to subtract the repeating 7s, but if it's an equation, you have to do the same thing to both sides. So if I subtracted that from the right, I have to do the same thing and subtract it from the left. Okay, so now let's see what we get. So 7 minus 0.7 repeating is going to be 7. But look on this side. I have 10n minus 0.7 repeating. If you remember much, you can't subtract these because they're not like terms. So now I have to figure out, well, I can't take 0.7 repeating away from 10n. I have to take away an n counterpart, right? That's a like term. But if I look up here, I have that n is equal to 0.7 repeating. So subtracting 0.7 repeating can be the same thing as subtracting n. Okay? Sorry, I messed it up. Okay. So that means I can, instead of subtracting 0.7 repeating, this eraser is too big. I'm going to subtract 0.7 repeating from the right side because I can do that. But instead of subtracting 0.7 repeating over here, that's not a like term, I can take n away because n and 0.7 repeating is the same thing. So subtracting the same number in different forms. Now I have like terms on both sides. So I have my 7 over here. And then if I have 10 n's and I take one of them away, we're left with 9n. So now, if I need the fraction, well, how do I solve something like that? How do I get n by itself? 9 times n is equal to 7. Get rid of your 9 by dividing. We get n is equal to 7/9. We're going to do the same thing for part B, and then maybe you're going to start noticing a pattern that's happening here with these repeating decimals. So I have n is equal to 0.3232 and so on. It's a little bit different because now I have two placeholders that are repeating. So if I have two placeholders that are repeating, I'm not going to multiply it by 10. I'm repeating all the way down to the 100th place. So I'm going to take a 100 and multiply both sides by 100. So I have 100 n is equal to, if I multiply by 100, I have two place values that my decimal point is moving. So I have 32.3232 and so on. Now we're going to pretty much go about this the same way. Okay, I need to get rid of my decimals. So how do I get rid of my 0.32 repeating here? If I have 32.32 repeating, I want to get rid of my 0.32 repeating. I can subtract it out. But again, same thing we looked at over here. I can't take 0.32 repeating away from 100n, but I know that these are the same thing. So instead of subtracting the decimal version out, algebra tells me I can just take an n away. So if I have 100 n's and I take one away, that gives me 99n is equal to 32. Divide by 99. And we have that n is equal to 32 over 99. So now if you take a minute to look at both of these, something interesting is happening here, right? I'm repeating decimals, but look at the form that my fractions take. I was repeating sevens, my fraction was a single 7 over 9. I was repeating 32, which is 2 decimals, 2 place values. My fraction became 32 over 99. So if we look at the next one, I have 3.251251. So my 251 is repeating. So can you guess maybe what that fraction is going to be by this pattern here not doing that work? We're going to walk through it. First thing is that my decimal is 3.251 repeating. All of this math here I did with zeros, and it worked out really nicely. So all I'm going to do right now is ignore that 3. I'm going to take it off to the side. I'm going to get rid of that. And now I'm going to say n is equal to 0.251 repeating. Okay, so now I'm going to do the same work. I have 3 place values that are repeating, so that's to my 1,000th place. So now I'm going to go ahead and multiply both sides by 1,000. So I get 1,000 n is equal to 3 place values that my decimal is moving, so 251, and then my repeating decimal. So I'm going to get rid of that repeating decimal. Can't get rid of that, so I'm just going to subtract my n, again, because that first statement tells me that they're the same. So if I take one n away from 1,000, we have 999n equal to 251 divided by 999. Okay? So we get that our fraction is 251.999. But keep in mind, we changed the problem from the beginning. This is your fraction for 0.251 repeating. Remember, I had that 3 out front as my whole number, so not only am I 251 over 999, I'm 3. Okay? So what do you notice about that pattern? Think about it, because when we come back together as a whole group to discuss this lesson, we're going to talk about that pattern and see if you can maybe estimate what a fraction is going to be without doing all of this work. And I had 7 repeating, and I became 7 over 9. I had 0.32 repeating, and I became 32 over 99. And then I had 251 repeating, and I became 251 over 999. Okay, so that summarizes your first day of notes. Make sure to join back into the Google Meet at the appropriate time so we can all come together and summarize all of this stuff. See you soon, guys.